The second half of section 6.5 deals with perfect square trinomials. And you see some ugly rules about perfect square trinomials. You do not have to use this line of factoring. Let's start with the first problem that you see. I ask you to factor x squared plus 6x plus 9. When I factor this problem, I don't use any fancy rules. I just go back to previous sections. I open my parentheses where I know I'm going to have an x and an x. I look for the factors of 9 that add to give me 6. And so those would be 3 and 3. They'd be the same sign, both positive. So when I work those, I work them the old school way that we've done them. I don't work them this new perfect square way. But I do want to show you their rule. So what perfect square trinomials are is they are a pattern. And they are a pattern that works like this. You have a square on the front and you have a square on the back. Now I know in order to make a squared, I would have a, and in order to make b squared, I would have b. If you take those two numbers and double them, double means multiply by 2. If you take those two numbers and double them and you get the middle number, and so in our examples they're using AB, that's going to tell you that this is a perfect square trinomial and it fits the pattern. Once you realize that, all you have to do is put your A and your B in parentheses and then take the sign that's in the problem. And that's how perfect square trinomials work. Now let's go back to this problem that I worked earlier. I'm going to draw it up in blue. Let's see if it fits the bill for a perfect square trinomial. Here's what you do. I'm going to look at this x term and I'm going to see what makes x squared, and that would be x. I'm going to look at this back term and I'm going to think what squared gives me 9, and that would be 3. If I took the green numbers 3x and I doubled them, I would get 6x. Great, that's what I have in the middle. So that's how you would start these. See if they fit the pattern. If they fit the pattern, you're going to take the sign in the front. So I get an x plus 3, and I'm going to use that factor twice because it's a perfect square. And that's how the perfect square trinomial way works. You can do it the new way and write your answer as x plus 3 squared, or you can do it the old way and write your answer as x plus 3, and you're going to get the same, you'll get a correct answer either way. Both of those are correct. Let's try a few more. So in this next group, I'm asking you to factor completely, and we have x squared minus 10x plus 16. I know that the term that makes an x squared is an x, and the term that makes a 16 is a 4. If I double these, right now I have 4x, but if I double them, I get 8. This one doesn't have an 8. Since it's not an 8, that means this is not a perfect square. If it's not a perfect square, that means you have to factor by an alternate method. Okay, so that alternate method that we would use is just basic trial and error. My choices for x squared are x times x, and my factors of 16 that add, reading it backwards, factors of 16 that add to give me 10 would be 8 times 2. Remember, they're the same sign and they're both negative. So the answer to this one, it's not a perfect square, and the answer is x minus 8, x minus 2. My second problem on this slide is x squared minus 8x plus 16. Let's see if this one is a perfect square. The number on the front would be an x, and the number on the back would be 4. If I put those together, I'd get 4x. If I doubled 4x, I get 8x. So this one does fit the pattern. So once I realize that it fits the pattern, I'm going to take my x and my 4. I'm going to take the sign in the front, which happens to be negative, and I'm going to square it. So my answer is x minus 4 squared, and that one is a perfect square trinomial. Okay, we're still factoring. I recognize these to be hard trinomials, but I also notice that the problems I see on the screen are both begin and end with a square. If it begins and ends with a square, I would try the perfect square trinomial way. I don't know if it works or not, we'll see. The number square that gives me a 4 would be a 2 with an x, and the number square that gives me a 9 would be a 3. If I put those together, I get 6x. But the pattern says I have to double it. So if I double 6x, I get 12x. So that lets me know that this is a perfect square trinomial. So that means I'm going to have a 2x in the front and a 3 in the back. I'm going to take the sign that's in the front, which is negative, and then it's squared because it's a perfect square, and so it would be 2x minus 3 squared. Looking at our next one, it's 16x squared plus 40xy plus 25y squared. The number that makes 16 is 4, so that would be 4x, and the number that makes 25 would be 5 and a y. If I put those together, I get 20xy. If I doubled 20xy, I would get 40xy. If I doubled 20xy, I would get 40xy. So that lets me know that this is a perfect square. So I'm going to keep my 4x and keep my 5x. I'm going to take the front sign, and then I take that quantity and I square it. Now you might not have liked perfect square trinomials. I know that I don't, and I rarely ever use them. But you do not have to use these. If you had the ones like you see on this page with 4x squared minus 12x plus 9, you're welcome to work that like a hard trinomial. You do not have to use this new rule.